Hi, hello everyone. So last time we left off with basically our player that could move, and this time we're actually going to well create backgrounds and try to keep the player in the bounds and also create enemies as well. So, but first of all, let's just move our well basically our gameplay area. It's going to be a bit different, and I'm going to use 600 by 900. Okay, that works, and I'm going to center it. So you can wrap this canvas element basically in div element. So you can say div here, and then let's just wrap it so that it's centered. And here we can say style text align center, and it should be centered. That's perfect. That's exactly what I want. So now actually where should we start? Let's start with background. So let's just create a new entity which is going to be called background. And for background, what do I need to have? So I'm going to just say export class background. So we're probably going to need to load the content for the background next. So let's just go to our content. And here we can say basically background texture. Background, let's just say texture for consistency. And here we're going to load this background texture. It's not in assets. If you look at the assets, it's in backgrounds, and then we have black, blue, dark, purple, purple. I'm going to use the purple because it looks the nicest probably. So let's just try that. Where do we need? We need to pin content and then backgrounds. It's not background JPG, it's rather purple PNG. If we save it, it works, so it must mean that it's alright. So for our background, it's going to be really simple. So we're going to have constructor, and then we're going to have drawRect. Let's just make it private. And drawRect is going to be the size of our screen. So we need to paste the size here. So we're going to paste width number and then height, which is also of type number. Let's see. Then we can just say let's make this private as well. And then let's just say width height. Of course, it won't work yet. We need to create it first. So we need to also import direct. Here we're going to have update, and it takes the delta time. And then we're going to have draw, which will take sprite renderer. It's of type sprite renderer, and then we can just sprite renderer draw, not background. It's actually our content. Dot background texture. Draw sprite. Alright, that should be fine for now. And then in our main, we're actually going to need to expose somehow from the engine width and height. So this is unused. We can get rid of it in our engine. And then let's just create public client bounds. It's vec2 from values. Actually just vec2 create. So we need to import vec2. And then here somewhere we can just set the client bounds, and it's going to be canvas width and canvas height. All right, that's perfect. And then we can actually create our background. Const background. If I manage to type it right, a new background. And then we just create the backgrounds with our client bounds, and then we can here say background update, and we need to draw background before the player. Otherwise, if you draw it after the player, you won't see the player because it's behind the background. That's just the way that we design the engine because we're not using the z-axis. So one way you could also extend this to use z-axis. Okay, perfect. So now we have our background, but that's not what I want to have with background. I actually want it to scroll so that it appears that we're moving through the space. So basically, we're not actually creating thousands of backgrounds and then moving the player. It's actually going to work sort of like this, right? We have our background and then we have, sorry, maybe just different color. And then I need to freeze it. So we have our background. Let's imagine and then we have our player here. But our background, so that it appears like player is scrolling, our background is going to scroll downwards. So it will be somewhere here, it will just move downwards. So you'll see what I mean right now. So let's just say this direct, and then let's just say const scroll background scroll speed. Let's just say 0.25, and then we can say this direct not x. Actually, we're scrolling in y direction, and then if this direct y is greater than this height, we're going to do something. Not right now. I'm going to explain it in a second. So it's scrolling in the wrong direction. Okay, that's all right. So how should we handle this case? So basically, we're going to need two backgrounds, right? As one is scrolling downwards on our screen, it will appear here, 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 here. But then when it's out of the bounds of screen, so when our background has gone from the screen, we want to return it here. But we also need second background so that this happens. Let's imagine this is our screen and our first background is somewhere here, right? But then we'll have second background scrolling and then we're just going to reset it here. Anyway, it's kind of messy to explain, but with drawing. But once we do this, you will probably get it. So we're going to need private draw rect2. And draw rect2 is actually just going to be very simple. It's going to, y is going to be not the background. We're not scrolling it. We're actually just going to set it to this direct y minus this direct, actually minus this height. That's all right. So if we take a look now, it's not working because we haven't created this direct to. So let's create it and then we need to draw it as well. Okay, so now it appears longer because we actually have two draw rectangles. But once the draw rect or the other one, draw rect 2 that y is greater than this height, what do we want to do? Well, we just want to switch them, right? So we're going to do this const temp. Then we're going to assign basically draw rect 2 to draw rect and to draw rect 2 temp. So this will scroll now indefinitely. So what are we doing here? Well, just like I explained, right? So if we have our screen here, and one background is fully rendered here on the screen, and second background has scrolled somewhere past here, right? So what we want to do is switch them. We switch them, but we also restart the backgrounds here so that they start from here. So basically that's sort of how it works. So now you see this really nice scrolling effect. So that's it regarding backgrounds. So second thing that I want to do is just keep the player in the bounds. So we're going to do the same thing as for background. Essentially, we just need to pass width, private width is of type number, and private height is of type number. And we can just say somewhere over here, keep player in game bounds. So if our player, this draw rect dot x is less than 0, we set it to 0, and then else if this draw rect plus height. Okay, that's all right. So the first one is quite clear. So sorry, just some sound issue. So the first one is quite clear. So if I'm pressing now to go left, I cannot go. And the same thing is for right. Actually, the right is not working properly. Maybe I just haven't saved it. Okay, there is a bug here. Let's just disdirect minus. Let's try now. What am I doing? No, this is not restarting properly. So this is wrong suggestion. I'll just do it by hand. If this draw rect dot x plus, let me just think. I'm blocked here. Is greater than this width minus this draw rect dot width. Then we are going to set it position to this. All right, let's see now. Okay, still not working. Still not working. Let me just think for this for a second, because I'm not thinking properly. So if our player act, so this is our player. Let's just move it here. Let's just move player here. So we have to take account this is the rectangle, right? And this is position X. So if our position X plus width of the sprite is greater than this width, right? Then we need to set it to our X needs to be set on X minus width. Is that correct? Yes, that's correct. So if our direct so is greater than this width minus direct width, that's all right. We set the draw x to this width minus direct width. This should be actually correct, no? But of course. All right, I get it now. Okay, that explains it. Okay, all right, that explains it. I haven't passed the values to the player. All right, that works, but now we just have to do the same for height. And then it's going to be if this direct y is less than 0, then it should stop. So I cannot go up even if I'm pressing, and then we're just going to have second condition. And it should be similar to the first condition of width. So we're just taking into account height. And it kind of works. Well, actually it works, not kinda. So perfect. We also solved this issue of keeping our player in bounds. So now we're actually going to work on our enemies, and that's going to be a bit more involved, but I think we'll manage. It's not that hard. So for enemies, I'm just going to create interface enemy first. Why interface? Well, because you can have different types of enemies. So I'm for this video, I'm just going to have one. But if you want to, you can create multiple enemies with different behaviors. So it's going to have active. So it will just say if our player is active. It will have draw rect because we're going to use it to update positions. We're going to have update draw, and so this is already familiar. This update and draw, nothing too spectacular here. So then we're going to have what did I call it in my example? I believe it was meteor enemy. I actually wanted to use asteroid, but the reason why it's meteor is because in our, if I look at the sprite sheet, if I search for meteor, not here, actually here, the assets are called meteor. So yeah, I'm just going to copy all of these meteor assets because I'm going to need them. And then in our meteor enemy, let's just do this, export class tier enemy, and then it extends enemy. Which is exported, not extends, sorry, implements, because it's interface. So we need to implement those methods that are given by interface. And then here I'm just going to say const, what's it's going to be, meteor keys, something like that. And I'm going to paste this, and now I'm going to do a bit of cleaning up because I didn't want to copy paste everything. So let's do this. Let's multi-line it. And from here, I'm just going to go not here. I hate it when that happens. From here, or from here, let's just remove everything to the right. All right. Then let's see. I'm not going to use all of them, so I'm going to leave these big ones. I'm going to explain it why in a second. I'm going to leave medium ones. So medium brown. So I can get rid of this small, tiny. Actually, you can use whichever you want here, but I just don't find these tiny ones all that great. So here, this one is fine. Sorry about this. I'm usually good at multi-lining, but apparently not when I'm filming. And then let's get rid of this. And this we don't need, these small ones. This is all right. So this is just going to be public active boolean. Let's set it to true by default. Draw rect, we're actually going to assign it to constructor. So here we're going to need a couple of stuff. So let me see. So I'm going to need game public, game width of type number, public, game height, similar to what we already had before. And then what we're going to do is get this key from our keys. All right, so how can you fetch any random index? So we want to fetch random index from these. Well, you can use matfloor and then just use matRandom. MatRandom is going to give you random value between 0 and 1. And then you just multiply it by the length of the keys to get that random number. And the matfloor is just so that you make it an integer, so that it's not a floating point number. That's why it's there. And then we could just say this direct is equal to content sprites. You use our key. We're just going to copy it. We're going to do the same for source rect. So let's move, and for texture as well. So we're going to have texture. And then we're going to have source rect as well. So let's do just that. So you copy from the source rect, you copy from the texture. That's all right. And we can already do some stuff with it. So let's do just this draw rect .y plus equals. All right, let's just create a variable for speed as well, which is going to be random, because we don't want to move everything with the same speed. So it's just going to be random, and then we can use matRandom. And let's just define meteor min and max speed. So let's just say const meteor min speed, and I use some value of 0.5, and then let's do just max speed as well. And then let's use random here times. So first we need to get, well, how will it work? And why is this done? Well, we need to get value. of 0.2 between those two, right? And then we just add min speed dots so that it puts us in 0.05 up to 0.25 space or domain. Then further, so we can just say this speed. And now we can actually render it. Why is this source not fine here? Aha, because we need to use this source. And that's it. So now we actually need some class that will render our enemy. So I'm going to use enemy manager here. New enemy. So let's see just how it will work. So we're going to have some constant variable, which is going to be called spawn interval. Sorry about this. I'm going to set it to 1000. And then we're just going to have our class enemy manager. What's it going to have? It's going to have time to spawn, and then it's going to have our pool of enemies. So I'm just going to say pool, and then in constructor we need width, we need height. We're not actually going to pre-fill pool, it's not necessary. So we're going to have update, it's a classic, and then we're going to have draw as well. And here, so if this time to spawn, not this, is actually greater than spawn interval, what do? Where we actually need to spawn the enemy. So first we need to reset this time to spawn to 0. And then we're going to say let enemy. So we're going to try to find the inactive ones from the pool. If there is no enemy, so we didn't find any, then we're just going to add it to array. So we're going to create it. So let's just use this meteor enemy and then add it to array. But it's still not done. We need to set active to true because we just fetched, maybe we fetched the inactive one. And then we're going to do this. So what does this do? Well, this is just means that we're going to spawn our enemy with the X position somewhere here, right, of the width. So basically it's going to be spawned somewhere on this position. Actually not, that's not true, because we need to take the offset, right? If you take a look at this sprite, the X is going to be spawned somewhere here. So that's why it's taking also the enemy draw rect width into account. Then further, do I need anything else? Okay. So we just need to set it, draw rect y. We're going to set it to minus draw rect height, y minus. Well, if our 0y is here, let's just get rid of it. So we need to set our sprite to start somewhere here, and then it's going to move downwards. So that's why that is done. And then, so let's actually move this. I'm just going to create private method, spawn enemy. And I'm going to do it here. And then here, what I'm going to do is say this time to spawn plus equals data time. So we increase this time to spawn. Then we try to spawn enemy. So if our time to spawn is greater than spawn interval, then it's going to be spawn. And this pool for each, I don't like this notation, so I'm going to do it a bit differently. So I'm going to say for let enemy of this pool. So what we're going to do, if enemy is active, we need to update it. And why is this done? So basically, if our enemy position y is somewhere over here, so our enemy has gone over the board, we're just going to set it to false. Active, we set it to false, right? So that we can reuse it. So he's out of the bounds, we don't care about him anymore, so let's set it to false. Alright, that's why this is here. And then we just have to draw it as well. So I can just copy this here. and say this. So if our enemy is active, let's just refactor this. If our enemy is active, then we draw it. Enemy draw, sprite renderer, we paste the sprite renderer. So let's see if this will work. Let's go to our, not engine, our main. And here let's just create a dead enemy manager. Alright, we're pasting the bounds, then we can update that manager. And then we can also draw our enemies. Does it work? No, it doesn't work because maybe I missed something. Here interface is missing. That's one. Let's just see what our bug is. Undefined. He didn't find a key? Oh, I know. So here in our enemy, our keys have PNG extension. So let's just get rid of it. You can say Control F and then just replace everything with nothing. So now it should work. Let's just remove this. And you can see we're already spawning, well, basically some meteors, but we're still not done. I want to add a bit of rotation just for aesthetic purpose. So let's do just that. So our rotation should be quite simple. Because I'm not going to take velocity into account or anything, I'm just going to randomly rotate it a bit. So I'm going to say public rotation is 0 and public rotation speed is 0 as well. We're going to have random, and then we also need public rotation origin, which is going to be vec2 from values 0.5, 0.5, because we want to rotate it around the center. So we can just say here this rotation speed is met. So I'm going to set the value to some space from minus 0.5 to 0.5, and then I'm just going to scale it a bit downwards. So I found this value that 9 looks, so this kind of gives a good value here. So let's just do this rotation plus equal this rotation speed, and then here, so for our color we don't have the color, and then I'm just going to move it to a new line. So we need to pass rotation and then this rotation origin. So interesting, it's really spinning too fast. So let's see what's up with that. Did I miss anything? Oh, I know. So multiplication goes first, so my bad. So I think this should be fine. Yeah, they're spinning slower, but it looks actually really nice. So that's it. But now that we have rotations, you're going to see some small artifacts here. So I had that problem also with the other tutorial series with WebGPU, and in the end I figured out that the easiest thing to do to fix those artifacts is because I think our content, our source recs actually needs to be reduced by 1. So that fixes it. And here it might appear a little warpy, but we can fix that easily if we go to our texture, and then we just, instead of nearest neighbor filtering, we just use basically linear filtering, so that kind of helps. So let me just see. So we need text parameter I, not this is wrong suggestion, I don't care about this. Texture min filter, and we're not going to use nearest, we're actually going to use linear. And let's do the same for make filter. Well, that should make it less warpy. So what are these filters? So just to explain it quickly, well, basically it just kind of when you have 2 pixels, let's say this thing is 1 pixel, and then we have other pixel as well, maybe of different color. So we have this green pixel. So you need to resolve this pixel in the middle, right? Somehow. So let's say our value is here. We need to somehow resolve the pixel. So if this pixel is near, it will fill this place with the green one. But coincidentally, if this is near, it's going to fill this with this value. But what if we have linear filtering? So let's say we have pixel here. We cannot decide on the with what value to fill this pixel. When you use linear, it's actually going to kind of linear interpolate it. I cannot show that really correctly, but it's going to use mixture of this color and mixture of this color. So it's going to linear interpolate it. So if we go from the yellow one to the green one, it's going to be yellow, 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 then some mixture color, and then it's going to become green as it goes towards the green. So if for example we have a value of 0 here, and then we have a value of 1 here, this thing will be maybe here, it will be maybe 0.25, and but here it's going to be 0.75, right? And then when it hits here, it will be 1, and here at the beginning it will be 0. So in the middle it will be 0.5. So that's what it means to linearly. So that's this interpolation that we have. With that said, I think we're done here. So this is perfect. We have our game. We have our enemies. We also have our scrolling background. So what's missing is we probably need to add bullets, and we probably need to add collisions between our player and our asteroids, and then also the collision between bullets and asteroids, and we might do collision between asteroids and asteroids. So we're going to do that next time because I don't want to make these videos too long. So if you enjoyed this video, please like, subscribe, and you can also follow me on Discord channel as well. So we have a discussion about WebGL, WebGPU series as well. So feel free to join the Discord as well. So until next time.